You are listening to the Business Talk podcast. I am your host Deepak. We are honored to welcome Dr. Xiao-Li Meng, Professor of Statistics at Harvard University and a globally recognized authority in statistical theory and data science education, as our esteemed guest on today's podcast episode. Dr. Meng also serves as the founding editor-in-chief of the Harvard Data Science Review. From 2012 to 2018, Dr. Meng was the Dean of the Graduate School of Arts and Sciences at Harvard University, following his tenure as a chair of the Department of Statistics from 2004 to 2012. Dr. Meng's research spans a wide range of areas, including statistical theory and principles, foundational to data science, philosophical and methodological issues in statistics, computational statistics, and signal extraction with uncertainty quantification in disciplines such as astrophysics and psychiatry. His pioneering work in multi-resolution, multi-phase, and multi-source interference addresses complex challenges in combining information across diverse data systems and sources. He is also known for his contributions to statistical computing, particularly Markov chain Monte Carlo methods, EM-type algorithms, and multiple imputation. Dr. Meng earned his PhD and MA in statistics from Harvard University and his BS in mathematics from Fudan University, China, where he also completed graduate studies in mathematical statistics. Prior to joining Harvard, Dr. Meng was a faculty member at the University of Chicago and a research associate with the National Opinion Research Center. His academic journey reflects a deep commitment to both advancing statistical science and reimagining how data science is taught and led globally. In this episode, Dr. Xiao-Li Meng shares valuable insights from his academic leadership and research journey in the field of statistics and data science, centered around the theme Innovating Data Science Education and Leadership Lessons from Dr. Xiao-Li Meng's Journey. The conversation highlights his pioneering contributions to interdisciplinary education, institutional transformation, and the evolving role of data science in society. So, without further delay, let's welcome Dr. Xiao-Li Meng to the podcast. Dr. Meng, thank you for graciously accepting our invitation. It's an honor and privilege to have you join us today.
Well, thanks for having me. Thank you.
Yeah. Dr. Meng, you have played a foundational role in shaping modern data science education. What motivated you to launch the Harvard Data Science Review, and how do you see its role in bridging academia, industry, and public understanding?
Thank you for the great question. And I was approached, I think it was during the November or October of 2017, by my colleague from a biostatistics professor, Francesca Dominici. She is the co-founding editor of co-founding director of Harvard Data Science Initiative. At the time, she was talking to various deans about how do we work together to create a data science initiative that will benefit not only Harvard, but broadly the data science community. At the time, I was serving as the Dean of the Graduate School of Arts and Sciences. And when she talked to me, an idea came to my mind at that moment was say, well, why don't we create Harvard Data Science Review? What I had in mind then was that, data science was a buzzword, many people talk about, but it was not clear what that means. Then also there was not a common forum for people who consider themselves data scientists or are interested in data science to get together to have serious, communications, debate, discussions. And so that's what I thought about creating the Harvard Data Science Review, because we have the brand name of the Harvard Review. There's a Harvard Business Review, Harvard Law Review. And I thought, Harvard obviously should take a leadership in this dialogue. And so I thought it'd be great to provide such a forum. So I made the suggestion, and what had happened, you probably have guessed that, afterwards, my colleague Francesca talking to her co-director, David Parks. Now he's now the dean of the engineer school, and they liked the idea, but they came back to me saying, well, Xiao-Li, it's a great idea, but you have to do it. And so that's how it happened. And it just happened that I was completing my deanship at then. So it was pretty natural for me to take on this new challenge.
Very insightful. Doctor, from your early teaching days to leading Harvard's Graduate School of Arts and Sciences, How has your approach to pedagogy evolved, especially in the context of statistics and data science?
That's a terrific question. And thinking about my own education journey, I was trained as a pure mathematician to start with, as many of us were. And so I remember my first education experience was when I was at Harvard serving as a teaching fellow. My first time when I was doing it, I saw the whole idea of being a teaching fellow is just to showcase how much I have learned myself. So I started, give formulas, talk about details, and didn't go well at all. Over the time, it's a long process, but over the time, I gradually learned that to teach well is really not about showcase your knowledge. To teach well is really about communicating, make sure others will understand. And so I think that has been my guideline. But along the way, I also learned the best way to learn something is to teach it because you cannot really fake it when you're teaching it. So I basically have developed a belief and a practice that only when I can teach something from multiple different angles, tell multiple different narratives that will feel comfortable that is a material I truly understand. So the teaching and the learning has been a very integrated part for me, and I trying to convey that idea broadly whenever I promote education.
Dr. Meg, what does elegant statistical thinking mean to you? And how do you translate that elegance into your teaching and mentorship?
I think that you probably have read my website. I put down, I love elegant mathematical statistics. The reason I use the word elegant, I think that was a bit background because when I was trained as a pure mathematician, it was not about can you prove something. We were all very working very hard. We can prove many things. It's about how do you prove something elegantly. How do you use the shortest proof? How do you make the argument concrete, rigorous, concrete, without extra line? And so I saw for me the elegancy really here referred to a clear logical thinking, a very efficient expression, and I think all these turn out to be fundamentally important, not only for being a dean or being a teacher, being a data scientist. I think most of us these days are so busy. We all appreciate people can get to the point in a very efficient way, but at the same time, not watered down with kind of precision, informative with substance. So it's not easy to do that, but I think it is something that I kept in mind, and I use the phrase "elegant" to as a summary of these criteria.
You have written about multi-resolution and multi-phase inference. How do such complex ideas influence how data science should be taught and practiced?
I came to this idea now it's over 10 years ago. I was asked to contribute an article to a volume called The Past, the Present, and Future of Statistics by the called COPS committee. COPS committee is a committee of President of Statistical Society. I was one of the recipient, fortunately, back in 2000. And at the time, there was a volume to celebrate the 50 years of the COPS, and the idea is to invite all these awardees to think about broadly about statistics, particularly with the evolving role inside data science. At the time, AI was not much emphasis like now. So obviously, think about more AI now. So I was thinking about my own journey. Was thinking about ways to how do we elevate the foundational thinking of foundational thinking of statistics into this broad field of data science, and to make some real, serious contribution. And at the time, I thought about the three theme, what I call the multi-source, referring to you have data not just from different bases, but it really have a different kinds, different modules, different qualities. And also the other thing I call the multi-phase, because if you think about data science these days, very rarely that a project is complete by a single person or single team. Somebody collects data, somebody actually conceptualizes data, somebody collects data, somebody did a pre-processing, other people analyzing, then may have different interpretations in the policy making. So you have all kinds of different phases. So I thought about how do we think about all these things together. And then the other one is multi-resolution, because now these days because the availability of the data, we ask a deeper and deeper question. I personally have been working on things connecting satellite image with ground level, poverty data. There's a lot of image, comes with resolution naturally, but there's a resolution in a very broad sense in terms of policy, at which level you want to apply the policy. We talk about personalized medicine. So that's how I sort about all these different kinds of complexities, their common theme. And I come up with this kind of a three multi framework, which I'm now teaching a course on it. And I have a pretty cliche title called Deep Statistics, referring to kind of a deep thinking dealing with these complexity. And I think, let me say very quickly, the one commonality with all these kind of complex problems, there's simply no right answer. There are many wrong answers, but there's no right answer. It's all about how do you think about trade-off, the compromise, the traditional bias variance trade-off, but there are data privacy, data utility trade-off, there are all kinds of trade-off. And that's at the core of this multi kind of a framework thinking. And I'm encouraging my students to really thinking broadly, not just think about analyzing the data.
Excellent. Professor, during your time as a dean, how did you balance academic leadership with research? And what lessons can emerging academic leaders in STEM take from your experience?
That is another terrific question. And, at the time I was asked to become dean, my first response was, do I still have time to do research? And my boss was telling me like, okay, the university is more important than your individual. So I said, okay, I will do it. But how do I balance that? It turned out to be, it's crucial that I talked to some of my predecessors. They actually advised me saying, it's very important for you to keep teaching. Even when you're a dean, not just about doing research. Research is still relatively easier because you can think about research problem when you're on a fly, when in a hotel, right? And I actually enjoy those moments because I have less distractions. But most important is also to keep teaching. And I was told the benefit of keep teaching is because particularly for a dean of graduate school, you will be, kind of on the ground, understand what students need, what the students want, what's on their mind. So I kept that tradition, which was great. But the other thing I learned, and this is my message to all the deans out there, teaching is also the way you protect your time, because even when the president said she or he wants to see me, I say I'm teaching, that time is protected. So if you want to protect some time for yourself, particularly deanship is a challenging job or any of the administrative jobs, keep some teaching time, because in university, teaching the first priority. Nobody tells you, cancel the class and talk to me.
Dr. Meng, interdisciplinarity is central to your work. How can universities foster better collaboration between fields to build data science programs that are truly integrated?
I think that this has been something we emphasize over many years, which obviously incredibly important. But I think we now face a new kinds of challenge because the industry speed scale is a lot faster, a lot bigger than what we usually handle in university. So I think these days the way to think about them, I was thinking about we should start thinking about not just the traditional interdisciplinary work, which means that each discipline still has pretty clear identity, and you have your own infrastructure, you have own culture. We should really think about a lot more blended, people call it transdisciplinary or multidisciplinary, I think. But most importantly for me, I think even these terms are still not enough. I think what we should have is a new kinds of education entity that will directly involve the industry for training and answer the industry question. And I also remind everybody, particularly data science, no matter how much we do in university, no matter how much money we have, sometimes people think about industry as just money. There's one thing we have to keep in mind that no matter how much we do in academia, we will never have that kind of data that the industry have. And that's just the fact of life, because we're not running the company, we're not collecting data. And you know how the data science AI pretty much is all driven by who has the data, high quality, lots of data. So I think university, even by the necessity of the data, have to work with industry in a lot more innovative. I don't know what the innovation would be yet. I think many things are being thought about, but I think some kind of groundbreaking innovation has to happen. Otherwise, there will be always a barrier that the simple access to data will be such an important issue for any of us want to make some real progress.
Dr. Meng, is AI technologies from adaptive learning platform to AI-driven tutoring begin to reshape education? How do you envision their integration into statistics and data science curricula without compromising the depth of human-led mentorship and critical thinking?
It's an absolutely terrific question. Very, very timely. I'm going to answer the question using some of my current experience. I've been starting, I think, only a few months. Back in March, I was invited to deliver a 3-hour AI assisted course on data privacy. That was an eye-opening experience, and I'm actually engaged a lot more in this kind of teaching. And the whole idea here is that to have the AI play the roles that can be scalable. For example, as a professor, when I teach, I have teaching fellows, right? But no matter which university you are, no matter how rich the university is, like having a few teaching fellows is feasible, but having a personal teaching fellow for every student, that's simply not possible, right? Even think about not just money, think about the kind of training you need for these teaching fellows. Excuse me. But now with the AI, especially with generative AIs, we are able at the beginning to use AI to do the personal training. The AI can be trained on the student's background, their interest, their questions, and the AI can play as a teaching fellow, a tutor, a peer learner, an evaluator, and even student. Remember what I said earlier on, the best way to learn something is to teach. So one thing we can do is now having a student to teach the AI become a student, teach the AI to see if the AI can understand. And AI is actually very good to prompt. I'm doing talk about reverse the prompting, right? We prompt the AI, but we want the AI to prompt us as well. And that's what I'm engaged in. And I think that this will be enormously useful. It doesn't take away the human interaction at all. It just enhance it, and in fact make it possible to do it in a much larger scale. And very recently, the team I'm working with, they made an avatar of me. So the avatar of me now is has a personal greetings to every student. We made it very clear it's an avatar. We also pose a question: how do you think about something like, the avatar looks just like me, the way it talks just like me? How do you think about it? What's the asset consideration? How do you think about usefulness, the dangers? So we also using these device themselves as a teaching moments to engage the students. This has been incredibly fun, and I'm quite sure it's something that one way or the other is going to go to classroom pretty quickly.
Professor, you have mentored many students and young scholars over the years. What principles guide your mentorship philosophy, and what do you think students today most need from their mentors?
That is a question deep to my heart because, yes, I've had the fortune to mentor many students, both graduate and undergraduate. Also, because of my role, both as the editor chief as well as I was a dean, I was department chair. I got chance to talk to many, young faculty, new researchers. Sometimes just people out of blue want to talk to me about and how do you become successful academia. Although one thing I made it very clear to everyone, if I talk to you about academia life, you can listen to me. But if I talk to you about industry life, I'm BSing. Okay, so just don't listen to me because obviously. So number one, obviously, you talk to the mentorship of philosophers. You have to convey things that you have experienced yourself. You have something substance to convey. But most importantly for me, that anytime a student come to me say, Professor Mann, I want to work with you, my first question for them is I want to know what is their strengths and their interest. So for me in statistics, now this may not apply to data science yet, but in statistics, I divide statistics into four major branches. Philosophy, theory. By theory, I don't just mean mathematics. Philosophical thinking is also causal inference. There's a lot of theoretical thinking. I divide them into theory, methodology, computation, and applications. Methodology developing, statistics developing, hypothesis testing, estimations, classification, all kinds of stuff. Computation is not necessarily is just implementing other algorithms. It could be developing algorithms. I worked quite a bit on EM algorithms, MCMCs. There are lots of algorithms are kind of a statistically informed, right? So I emphasize the difference between statistical computing and the computational statistics, right? There's some distinction there. And then there are applications. I will describe to my students, say, hey, here's 4 major branches of statistics. Tell me now which one that you find you have the most strengths for, and which one you're most interested in. Now you have to be careful. Just because somebody has a strength in something, it doesn't mean they're interested in doing that. I have students say, I've done enough theory. I want to do something applied, right? So you need to ask both questions. And I will, from there, I'm going to, talk to them because, the one thing is useful to talk a senior mentor, someone like myself now, accumulate like 35-year experience, but I know a lot of things, so I can kind of cherry pick which one for the student's interest. But there's one thing I want to kind of convey to those who, if you want some secret here, I find, at least for statistical students, that if they tell me, say, Professor Mun, I don't know what to work on, pick up one for me. I will always tease my colleagues, say, well, which one I'm going to pick up, right? Because, there are 4 of these branches. The lesson I have learned, statistically speaking, the one tend to be most successful is I pick up a computation. Okay. Theory is too hard. It will often intimidate some students. Serious application requires learning quite a bit of substantive field before you can see some results. And sometimes that discourages at the beginning when people say, I have no idea what I want to work on. Methodology development, if you can do it, it's great, but it's very competitive. There are many people want to do all kind of methodology. The computation part, because the reason I say computation is the students can always program something. First, learn the program, create some simulation. I can always give them some simulation. They can always read some output, say, hey, here is the results from my simulations. And so it's essentially, it's a process to build self-confidence. They see something on the paper is what they produced. Then we can talk. Then I can talk to them like, oh no, that part needs to be improved. We can do more simulations. So it's a relative speaking, it's an easy way to get, especially newcomer to research, to do something. Now these days, probably we don't even need to emphasize that because many youngsters come to us, they're good at computing this, computing that. But I would still suggest that using simulation study as an entry way to get students into some serious research. And so that is one thing I do with my students. Broadly for all the other kinds of mentoring, my interest here, I always talk to them. And I know this cliche to say, but it's truly true that you just have to find something that you like to do. There are times you do things because you have to make a living. But if you truly have a choice, even you don't have too much choice, you want to find something you manage to do. So my conversation with lots of youngsters are essentially during the conversation, to let themselves recognize what is their passion. Sometimes it's not clear. Like myself, I have lots of ideas by talking to people. When I talk to people, I started forming ideas. I just start, oh no, that was clear. So I basically use that as a way. I basically serve as a sounding board and provide a little bit of guideline. But that's pretty much is my general philosophy.
Professor, how do you approach professional development for faculty and students in a rapidly changing data landscape?
That is another terrific question. It's very related to the previous ones. I think the thing to do is you need to identify the incentive for people. You can't, particularly with the rapid change situation, everybody's busy. Tell them like, you have to teach that, you have to teach that. That does not work. That simply does not work. Whether you're dean, whether you're president, nobody, especially in universities, faculty don't have to listen to any of us. So the way is you really identify things they are interested in. There are plenty. And most recently, a few years ago, actually, not that recent, one of my colleagues say, hey, with all AIs happening, like, can we do a summer reading group, like just to figure out what's going on? There's so many things, like so many of us are sign on, right? Even we're so busy because we all want to learn, right? And it's not that hard. If you pay attention to what people are doing, have some conversations with people, it's not hard to identify what truly is their interest. So the one thing I do when I was a chair, when I was a dean, to motivate some of the colleagues to teach is really to identify topics that they're working on, they're interested in, and finding ways, workshops, seminars. We have freshman courses, things are maybe a little bit different from the traditional lecturing based, and to get them engaged with students, let them to see the benefit of having these students talk to them, right? Now, it does not always work, but if you create a culture of that nature, others will helping each other. Because at the end of the day, none of us want to be judged for not doing what we should do. But it's sometimes we drag our feet is just because too much burdens. And so this is the other thing that AI can help, right? Helping, organizing things, helping preparing, if AI can help with grading. Now, of course, human needs to be involved as well, right? So there are things you need to be innovative to create incentives for people to be involved. And the other thing I learned is really the best way to incentivize other people is not from you, but from their peers. And a peer pressure, whether it's for students, whether for faculty, is actually works much better than the top down. You come, you say you do this, you do that. That doesn't work well. The last thing in the academia world is most important is you should always be mindful of people's time. Whatever you want other people to do not create initiative. Other things people think you're just wasting their time. You need to find a ways they find. Actually, I want to say providing other people with some more time is probably the number one incentive in the academia world.
Professor, what role do values like curiosity, humility, and intellectual risk taking play in shaping a thriving academic community, especially in the data sciences?
I would say I value uh, all of them. Curiosity is absolutely crucial, right? In academia is particularly crucial. But I think these days it's not just academia. I think look at how the public has reacted to uh, AI, right? Even lots of public will be asking like, how did it work? I don't understand. That's a sign of curiosity. This is actually has been there are a lot more common the public curiosity happening than almost any other previous revolutions, right? Previous revolution when some medical breakthrough happens, everybody gets very excited, but not too many people would be asking like, how did that work? You know, because people just feel I'm benefited from that's important. Only academia, so people are doing it. But now for the whole generative AI things, particularly the ChatGPT, all the stuff, you know how like ordinary people are asking the question like, I don't understand how this works, right? That's great. So curiosity is absolutely important, and we do need to humility is particularly when we have a very powerful tool. Humility is particularly important because we all have tendency, even with all the goodwills, sooner or later, where something happens that we're not careful, it could have harmful effect, right? So just be always mindful about what we're doing as a part of the community, and truly understand for a human being, we really cannot enjoy the happiness if we do not have a community to share. That is just a fact of life, right? Nobody feels so happy because nobody talked to them. Okay, so you just need to think about obviously the humility has a much broader sense, but I'm just take a very practical perspective on it. And intellectual risk is something that we all take, and but I think particularly with everything happening, I think we need to for those of us particularly very very innovative and academias we are, and lots of industry leaders we are, that we do need to balance the intellectual risk, which is incredibly important, and with all the other considerations. So in a way that it's actually still the intellectual risk is just a higher order. It's like more for those of us understand, optimization. It's like you still want to optimize, but it's a constrained optimization. And we all understand, for those who have done it, constrained optimization actually intellectually is even more interesting than unconstrained optimization. So you just have to think about ways that taking this risk, make sure that the risk calculation here is not just the traditional your own risk. You should think about a community, think about other consequences, think about future generations. And once you start thinking about those things, that thing actually become intellectually a lot more rewarding. of course, also a lot more challenging, but I hope that's what we're here for, at least for those of us choosing more a kind of research-oriented career.
Professor, I would like to conclude this episode with one last question. Looking ahead, what do you believe are the biggest opportunities and responsibilities for leaders in data science education and research?
I think the biggest opportunity for all of us is that we can greatly increase our impact because the tools have become available. Now, it could be research impact, it could be teaching impact, it could be industry impact, whatever you're doing. But at the same time, because you can have a large impact, you do have a larger responsibility. I am the one always emphasize there's no such thing as a free lunch. So when you increase impact means that you can change things. But as you know, changing things could be changing for good or changing for worse or for bad. So you do have to think a little bit more careful. Essentially, it's very much like, if you're sending out an email to a small group, you probably say, oh, even to someone, you may not care that much about how you're writing the particular grammar, the sentence. Like someone like me, I have all kinds of typos. If I'm an individual, people understand me. But if I send to a large community, particularly on behalf of the university, I have to be very careful, right? Because it's a small example. It's just bad for someone like me to send out a piece with all kinds of errors, some misleading statement. People can understand differently. That's a tiny example, but the lessons are the same, right? And we just have to be much more considerate. But the harder part of the responsibilities, in order to be considerate for the large community, a large group, you need to understand them better. And understanding large communities, particularly outside your own comfort zone, is a lot more work than we, can do on a, anecdotal base, right? And so that's what I see. It's a scaling effect, but it comes with both the opportunity and the responsibility.
Thank you, Dr. Xiao-Li Meng, for sharing your remarkable journey and deep insights into data science education and academic leadership. Your reflections on mentorship, interdisciplinary thinking, and the future of data science have been both inspiring and thought-provoking. We are sure our listeners will take away valuable lessons on how passion, innovation, and vision can transform not just classrooms, but entire academic communities. Dr. Meg, it's been absolute pleasure having you with us, and we look forward to following your continued contribution to the field. Thank you so much.
Well, thank you for giving me this opportunity, and I hope that it's useful for at least some readers or some audience. And the most important thing is my emphasis to think broader than we used to be.
Thank you.
Thank you.